Hello, welcome to Prajim Technologies. I am Venkat. This is part 23, Polymorphism in C Sharp. In this session, we will learn overriding virtual methods and polymorphism. Let's look at an example. In part 21, we have seen inheritance. In that session, we have learned that a base class reference variable can point to a child class object. This concept actually forms the basis for polymorphism. If you haven't already watched my video on inheritance, I would strongly encourage you to do so before continuing with this session. Alright, so in this example, I have already written a simple class called employee, which has got two properties, first name, last name, and uh, a method print full name, which will basically concatenate first and last name and prints their full name. Now let's say we have three different type of employees in our organization, part-time employees, full-time employees, and temporary employees. Okay, obviously any type of employee will have the first name, last name, and we should be capable of printing their full name. So all this code is common to every employee. So we have that in the base class. Now let's go ahead and create the respective child classes. First, maybe part-time employee public class part-time employee. So this class inherits from the employee base class. Similarly, we will have, maybe full-time employee, which also inherits from employee class. And similarly, we will have temporary employee as well. Temporary employee. So if you look at the example so far, it's pretty simple. I have an employee base class, part-time employee, full-time employee, temporary employee. All of them inherits from the employee base class. Now let's say, now from inheritance we know that all of these code will be available even to the child class. So if I create a part-time employee object, print full name method will be available to this part-time employee, full-time employee, and temporary employee. Okay, now let's say in my main method I want to create an array of employees, you know so let's call this employees is equal to new array of employees. Okay, and I want to be able to create four different types of employees. Now since this is an array, in the first element of this array I want to create, the type of the object is employee. Okay, and then maybe in the second one, employees of 1 is equal to new part-time employee. Now, is this possible? Absolutely. In the inheritance session, we have seen that a base class reference variable, now this employees is just a reference variable. So a base class reference variable can point to, a child class object. Based on that concept, we can assign a child class object to a base class reference variable, because a child class is a specialization of its base class, meaning a child class has all the capabilities of its base class plus whatever are the additional features that the child class has. Similarly, employees of 2 is equal to new full-time employee, and similarly employees of 3 is equal to new temporary employee. So now all we have done is we have created an array of employees, and then to each element we have assigned a different type of employee object. Since these classes are all related by inheritance to the parent class reference variable, you can assign the respective child class objects without any issues. Now let's say if I use an array to loop through each employee object. So for each employee, maybe E in employees array, because if you remember, you know though this is a child class object, since these classes are inheriting from the employee class, all the code that is present in the employee class is available to the respective classes. So that fact allows us to, assign a child class object to a parent class reference variable, and also allows us to invoke any of the parent class method. So in the parent class employee, we have print full name. So I'm going ahead and printing that. Now look at this. The respective child classes doesn't have print full name method. Okay. So obviously the parent class has it, and that will be invoked. So let's go ahead and run this program. And remember, in the employees array, we have 4 different type of employee objects. So if I go ahead and run this, as you might expect, the print full name is called for each object. And since the child objects doesn't have their own version of print full name, the parent version is called, which prints just the first name and last name, because they are initialized to their first name and last name. Now let's say I have a requirement. My manager said, okay, that's fine. We are able to print a part-time employee, full-time employee, temporary employees, first and last names. But what I want is, along with their first and last names, if he's a part-time employee, I want, an indicator, a visual indicator like hyphen part-time. And if he's a full-time, the output should be as shown in this notepad. Okay, so how do we do that? Okay, that's when we will actually have, the respective, um, in the respective class, we will have a print full name method as well. Now, if I go ahead and implement that for part-time employee, so for part-time, all we have to do is, all right, to the first and last name, I want to concatenate part-time string, just like that. Similarly, for the full-time employee, and for temporary employee, and this is going to be full-time, and this is going to be temporary. Okay, so now each class has got its own specialized method or overridden method. But now what happens is, if you have the same in the child class, I'm having a method name which is very much similar to the parent class. Now if we do that in the last session, difference between method, in the last session when we spoke about inheritance, we have seen that it will actually hide the method. In method hiding session, we have seen that. So if the method in the child class has the same name and same signature as the method in the parent class, this literally hides the method in the base class. Okay, but now since we are using a base class reference variable, even though you have a specialized version in the child class, the base class, method will be called. So if you look at this, if I go ahead and run this, you will actually look no difference in the output. And if you look at, we'll get 3 warning messages, one for each specialization, one for each derived class. So for part-time employees and full-time employee. And what this basically is saying is, this print full name method is hiding the method that is present in the base class because they have same name and signature. And if your hiding is intentional, then use a new keyword. That's what this warning message is saying. So if I want to really hide that, I can use a new keyword, but that's not our intention. Our intention is basically to override the definition that is provided by the base class, and to do that you have to use the override keyword. But before we do that, we have to mark the method in the parent class as virtual. And I'll tell you the reason why you have to do that. The moment you mark a method as virtual in your parent class, it basically indicates to the derived class, any derived class can override the method, the virtual method, if the derived class wish to do so. Okay, otherwise they can leave that. If they don't override, then the base virtual implementation will be available to the derived class. So basically what I can do is, look at this. if I just delete this implementation, and if I type just override, and then if I press space, look at that, the IntelliSense shows me there is a method called print full name which can be overridden, and if I just select that, automatically the signature method will be inherited. Okay, so public override void print full name. And what do we want to do? Since this is a part-time employee, we want to print their first last name along with this hyphen part-time, you know, string literal. Similarly, instead of void, we want to, I'm sorry, instead of override, I mean, we have to use the override keyword here, and for the temporary employee as well. So what changes have we done until now? In the base class, we mark the method as virtual, and in the respective derived classes, we are overriding the implementation. So if we go ahead and run this program now, though the reference variable is of type parent, at runtime, you know, the runtime actually checks, okay, what kind of object do I have? If it is a part-time employee and if somebody is calling the print full name, then I want to invoke the overridden print full name method in that respective child class, which will make these respective overridden methods in the respective classes to be invoked, okay, at runtime. And that's nothing but a polymorphism. Okay, polymorphism basically enables you to invoke derived class methods through base class reference variable at runtime. That's nothing but polymorphism. So if I go ahead and run that, we will get the output as we have expected. So first name, last name, and for part-time employee, we should get part-time, full-time, and temporary. But on the other hand, look at that. For example, let's say for a temporary employee, I am not providing any implementation. I am not overriding the method in the base class. If I do that, then what happens is, since this temporary employee object doesn't have any overridden method, the base class, virtual method implementation will be used for this last employee. So if we go ahead and run that, since part-time and full-time employee classes has the overridden methods, the respective overridden methods will be invoked, whereas for the temporary employee, we don't have the overridden method, so the base class virtual method implementation will be used. And similarly for the first employee, it's the employee object, the base class type itself, so the virtual implementation will be used. So this is nothing but polymorphism. So if somebody asks you what is polymorphism, you can just say that in one very good statement. Polymorphism enables us, okay, to invoke derived class methods using a base class reference variable at runtime. That's polymorphism. Okay, so let's go back to the slides. So polymorphism is one of the primary pillars of object-oriented programming. Polymorphism allows you to invoke derived class methods through a base class reference during runtime. In the base class, the method is declared virtual, and in the derived class, we override that method. And this virtual keyword in the base class indicates that it can be overridden by any derived class. And on this slide, you can see additional resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.